From finance too.
The volumes that we were seeing there today that's been taken out of freshwater lakes and rivers and so on is really unsupportable, and ways do have to be found to reduce this water use. And so it is incumbent upon us through our governments to support rigorous surveys and assessments of surface and groundwater systems. As has been pointed out, the federal geological surveys have not been doing this. They've not been funded adequately to do it. Provincial water use for the shale gas industry has been handed over from environmental regulators to oil and gas regulators, so there's all the wrong pressures are there to conserve water. Oil and gas regulators, they're of course to regulate and promote oil and gas, not to think first and foremost about environmental issues. So that's another concern as well. So I think that we need to end with the idea that because of the increasing complexity and environmental issues surrounding these non-conventional resources, there is a tremendous need for industry responsibility, and I'm not saying it's not there at all. I think it's growing. But also because of the public, through our taxpayers, through well-funded and well-planned government scientific research, is becoming more and more essential if we are to preserve any kind of environmental balance going forward into the future. So, thank you.
Next is Tom Myers. Tom is an independent researcher and consultant in hydrogeology and water resources. His academic background includes a BS in civil engineering from the University of Colorado and an MS, Master of Science, and PhD in hydrology and hydrogeology from the University of Nevada, Reno.
Is that this thing on? I guess I'm next. It sounds like it's on. I mean, first of all, you might wonder why a guy from Nevada, Reno, Nevada, would be working on shale bed natural gas. I got involved with the New York environmental impact statement process, and I've also worked a lot on coal bed methane in both Wyoming and Montana, and hence my background in this issue here and everything. I found Ben's paper to be rather quite well written, well documented. Some of the things I came across before in doing research on the New York EIS process. I mean, being a hydrologist, I could expand on many things in that paper, and I'm going to focus on one thing after just a couple of very brief comments on other things. I mean, he really laid out well the idea of issues on water quantity, and I'll just point out. I mean, just one example I saw this past summer. I am from Pennsylvania, and I was there, and I see a truck pumping water out of an almost dry creek, and below the creek it is dry, and this is a creek that is not normally dry, and I believe you need to have some requirements or regulations around when surface water withdrawals can be made that have, that say perhaps no withdrawals when flow in the stream is below the median or something to that effect. I mean, some kind of restriction. I'm not prepared to lay out exactly what that should be, but at the moment. But in August, when it's almost in drought situation, it's probably not a good time to be pumping water from the creeks. But the paper lays out that there's three main sources of contaminants from this type of development. One of course could be the fracking fluid, and that's before, during, and after the actual operation. The second source is methane movement through the groundwater, and the third is the shale bed water itself, which can be extremely high. Well, it's also called the produced water. It can be extremely high in total dissolved solid, salt, and also in some areas high in naturally occurring or naturally occurring radioactive material. The receptors place things that can be contaminated, of course, are groundwater aquifers, streams, lakes, and wetlands, depending upon how it gets there. And there are, as I've identified it, about 5 different pathways for some of the contaminants to get to the aquifers or to surface water. I mean, one, of course, could be a spill on the surface during fracking or just during the operations. I mean, last night as I checked into the hotel and I turned on my computer and looked, and I got this Google alert, Marcellus Shale. There was an article in my hometown newspaper of a truck that had been delivering fracking fluid to an operation, had dribbled fracking fluid down the road for 30 miles. That's one way that you get a contamination. It had been pulled over in my hometown. I mean, the truck had been, because it had been leaking this material. So that's one way of, a spill on the surface causing contamination. I mean, there can be a blowout or a spill during the capture of return flow. There can be leaks from the well bores. The well bores are rather well constructed, but they're not perfect. As I think was just pointed out here, there's a discharge of the return flow, especially in Pennsylvania, they're doing it to surface water, and whether there's proper treatment of that. And then there's also the possibility of movement from the shale bed into the inner burden. And that's actually the one area that I want to focus on the most, because I think it's perhaps the most interesting area that I came across in doing my research. And one concern, that's going to be the thing I want to focus on, but a common concern around fracking, of course, is spills and leaks that could occur during the operations. Technology, regulations, enforcement, they will evolve, they will improve, but accidents will continue to happen. It's like, I do a lot of work in the hard rock mining industry, and I think the same line applies here, and that is the industry doesn't design a well or a fracking operation to fail. But I found that almost 75% of hard rock mines have some kind of water quality issue. I don't think it'll be quite as high with fracking, but they don't design them to fail either, because every time you have a failure, they lose money. And so I know they're not. The wells are designed well, but accidents happen. And adaptive management perhaps may be the best way to handle this, and that is that we need to set up monitoring wells and monitor groundwater quality between the wells and the potential receptors like a domestic well. I mean, monitoring a domestic well, I don't think is sufficient, because once it's contaminated, the damage has been done. We need to do some monitoring between the source and the potential receptor. The longer-term problem, and Ben mentioned it briefly in his paper, is the potential movement of shale water or fracking fluid from the shale bed into the surrounding aquifers. That could either occur through fracking out of formation, or when fracking enhances an existing fault or pathway between the formation and the surrounding interburden above the shale. My concern here is not with contamination reaching these receptors during the fracking operation. The contaminant is not going to travel on a 5-day period from the formation to a surface aquifer. And one of the analyses in that environmental impact statement basically said it couldn't happen because contaminants aren't going to flow in 5 days from the formation to the surface, and that seemed kind of like almost a ludicrous argument against it, because there's really no hydraulic connection established within that 5-day period. It's more of the problem is that you have a huge gradient established from the shale formation to just outside the formation. And if any of those fractures, be it induced by fracking or be it the existing fractures in the shale and surrounding material, as they are enhanced, will force some of that fluid outside the formation, and then it's just a matter of it getting to the surface, either straight up or down or along a pathway somewhere.